Hello there. Today we'll be doing decode ways. I believe we have done this before in binary search, but this is a little different. In Leetcode, we're looking at these items where if we start at a 0, that means that we cannot process this. This means that it is an invalid input. And so but let's get to the problem and understand how it works and where we're going with this problem first. And then we will, handle that edge case. So let's say we start with 1, 2, 1. What we can do this in two ways, which is 1 or 1, 2. So what this means to us is that now there are at least two ways to get from 1, 2. Then we split the one from 1. We get the next two items and see how many ways is there to get the next two items. There are two ways to get the next two items. It's either 2 or 21. So then that means there are three ways to get items here. So 1, 2, 1 and 1, 2 and 1, 21. And here you get 12 and 1. There are a total of three ways. So what we're going to do is set the base case to be our final item here, which is going to be a 1, and a 1 here, and another 1 here. So every time we move forward in our top-down approach, we would add those, let's say, I guess, possibilities to our decoding. So here's what I mean. So we do a dp of equals to length and s at 1, and we do define our DFS call at I. So if I in dp, we're going to return dp at I, which is our base case, which is at 1, our final item. If, however, we're handling the edge case where it's equal to 0, then we're going to return 0 for that particular location because it is impossible to get anything. Yeah. So anyways, so we're going to set the result of our current location of I, let's say it is 0, to be DFS of I plus 1. So I plus 1 is, we're going to take the 1 and we're going to ask for everything after. And then we're going to take, if it is possible to take two numbers, then we're going to add the next everything, add those possibilities to our location. So if I plus 1 is length of s and s of I is equal to 1, or s of I is equal to 2, and s of I plus 1 is between 0, 1, 2, 3, 4, 5, and 6, then we can add that particular number. So there are better ways to do this. There's a bottom-up approach, which is possible, but we should be doing that in the next video. This first video is to get ourselves clear about what we're trying to do in this particular problem, which is to get caching the result and returning the result at that particular item. So how we run this code is for 1, 2, 1 is that we start at 3 and 1 and 2 and 1. So basically we have this DFS, we have, let's say, 0, 1, this is 2, this is our last, and then 3, this is our third item. So, And at the third item, when we get there, we're going to return 1. That's currently our 1. So we're going to return the result of the first item, which is going to take from DFS of 2, because so let's actually run this properly. So let's run DFS, call DFS of 0 first. And what that happens with that is that DFS of 0 is going to call, is DFS 0 in the DP? No. If it is it 0? No, because it's 1, 2, 1. And so what we're going to do is we're going to call DFS of 1. And DFS is 1 is 2. And so DFS is 21. This is going to be, let's say, 121, and that means that we can continue calling DFS of 1 of 2. If we call DFS of 2, which is going to be a 1 item, a string is going to be 1, then of course we're going to keep going and see if we can call, yeah. So we're going to keep calling a DFS of 3, which is going to be equal to 1. So we're going to return a 1 to DFS of 2. So DFS of 2 is now equal to 1. And the result is going to be 1 at this point. Afterwards, we see that it is a 2 and it is within 21, so we run DFS plus equals 1 plus 2, which makes this a 1 equals 2. Afterwards, what happens here is that we find that DFS of 1 is equal to 2. And we add DFS of 2, which is equal to 1, and we get a total of 3. And that's how we end up with 3 here. So as you can see, this represents our chart exactly as how it should be. And so we have 2 from this particular 1 option and 1 option from the 2 option. If we took 2 from this 2 spot, as you can see here in our graph, in our tree. So this is our top-down approach. Hopefully I explained it as clearly as possible. I don't know if I did, but we're gonna do one more review after I submit this code, and we will talk about it some more. Right, what's going on here? Right, this is not within the right line of code. And let's submit. Okay, so looks like we have a very slow time this time around. You just don't know what's gonna happen. So in this solution again, we are doing a top-down approach where we take 1 item and we take the possibilities of DFS of I plus 1, and then we take the possibilities of I plus 2. We would take 2 items ahead, and that's how we come to our answer. We also, by using the cache system that allows us to figure out, we can store the items into our DP, and so that we can pull those possibilities from that location, from that location when we get to it. Next, we're going to do a bottom-up approach in a second video, and I hope you learned something today, and we'll follow up on that bottom-up approach later. Thank you very much, and I will see you in the next video.